So question 7 involving rational functions is we want to find the vertical, horizontal, and oblique asymptotes, if any, for the following rational functions. So notice how they're now giving us a rational function. So before they gave us the graphs. So some things to pick up on though are we've already kind of talked about how to find a vertical asymptote. It's kind of a domain restriction. But to find horizontal asymptotes, it's about the degree of the numerator and denominator. So here's some things to pick up on is this. So the horizontal asymptote is going to be y equals 0 if the degree of the denominator is greater than the degree of the numerator. So there's going to be a horizontal asymptote is going to be y equals 0 if the degree of the denominator, that means the bottom, if the bottom degree is larger than the degree of the top. So remember, numerator is top. So if I look at this problem right here, notice that the degree of the top is a 1 because the exponent of the x is a 1. And the degree of the bottom is a 1 because the first term has a degree of 1. But remember, a constant has a degree 0. So the degree of the bottom has a degree 1. So this is not going to hold true because the degree of the bottom is not greater than the degree of the top. The second scenario is the horizontal asymptote is going to be y equals the leading coefficient of the top divided by the leading coefficient of the bottom. So the leading coefficient of the numerator divided by the leading coefficient of the denominator. And that has to be simplified. This happens if the degree of the denominator and the degree of the numerator are the same. So if I look at this, notice that the degree of the top and the degree of the bottom are the same. So that's going to be the one we would use here. Also, it says there's going to exist an oblique asymptote if the degree of the numerator is 1 more than the degree of the denominator. We have to use long division to do that. So if we look at our example, we have y equals, if I put this 5x, put a fraction here, whoops. So y equals and alpha f1, if I put 5x over x plus 14. So that don't look right. That looks okay. So if we graph this, we kind of see, there's my graph. Now it's just part of it, because like I said, I may have a bigger window. But if we look at the table in this problem, I don't like these fractions. Look, let's change this back out to, let's just put 5x divided by, in parentheses, x plus 14. Graph it that way. So same graph. Notice now I got decimals. So one of the things we pick up on is the horizontal asymptote is going to be a horizontal boundary. So what happens is if we look at the extreme values to the left and to the right, typically, what's the y values doing? So if we look at it as x goes to infinity, as x gets larger and larger and larger, notice that my y values are not getting very big. They're barely moving. So what we're seeing is they're approaching 5. So what we can pick up on is, if you look at the leading coefficients in our problem, we're going to have y equals, the leading coefficient at the top is a 5. The leading coefficient at the bottom is a 1, and 5 over 1 is 5. We can kind of see that happening here, looking at our table. So what happens is, for asymptotes is, as x approaches infinity, what's y approaching? If y is approaching a specific value, then we have what's called a boundary line, because that means it's never going to touch it. It's not going to cross it typically. If I go the other direction, let's see if the same thing happens going to negative infinity. Notice that it's actually coming from the other side. Notice how it's up high. It's approaching 5 from the other side, above the asymptote. So we do kind of see, as x is approaching negative infinity, as x gets bigger negative, we're also seeing y is approaching a specific value, which is 5. And that approachment is also called a boundary line in this problem. So that's kind of what we're seeing here. And that's essentially how we find a vertical asymptote is you're asking yourself, what happens when x is really, really large? So notice that if x is really, really large, this adding of a 14 isn't going to affect the problem a whole lot, because a million, like if I had say a 5, if I picked x to be a million, if I looked at this from that perspective, that'd be like 5 times a million on the top, 6 zeros. And on the bottom, so if I have the bottom, that would be like a million plus 14. So now essentially what we have is 5 million divided by 1,014,000. Notice that essentially what we're getting is something really, really close to 5. So notice that adding this 14, when x is really, really large, it's not really affecting much in this problem. So that's why these little shortcuts can kind of help us out here instead of trying to do all this math on the calculator. So horizontal asymptotes are going to exist if the degree of the numerator, if the bottom is greater than the degree of the numerator, it's going to be y equals 0. And then the horizontal asymptote is going to be y equals the leading coefficient divided by the leading coefficient of the numerator and denominator if the degrees of the numerator and denominator are the same. And that's what we have here. So this function does have one horizontal asymptote, and it's going to be y equals 5. So the next thing is, do we want to find any oblique asymptotes? Again, if there's a horizontal asymptote, then there's not going to be an oblique asymptote. So that's going to be no oblique asymptotes for that. So the bulk of the work here is trying to find these asymptotes. Let's see if we have to find a vertical one now. Let's see, did we find a vertical? I don't see the vertical one. So to find a vertical asymptote, remember, what we did is we set the denominator equal to 0. So I'm going to use like v dot a. So the vertical asymptote, we have the x plus 14. We set the denominator equal to 0. If we solve for x, we get x equals negative 14. And remember, the vertical asymptote is the equation x equals negative 14. So if you looked at our table, when we got to negative 14, we probably saw an error. That was a domain restriction, which means that's where our graph does not touch at that spot. Okay, so we're getting closer there. So notice that negative 14, we got that error. That's going to tell us that there's a domain restriction, which also is going to represent a vertical asymptote when we're talking about rational functions.